Hi everybody, today we're going to talk about how to find the number of protons, neutrons, and electrons in an atom. If you want to follow along at home, you are going to need supplies. We're going to start today talking about my very favorite element. Carbon is my favorite element. It's because that's what all my students are made from. In fact, all living things are made mostly from carbon. There's a whole branch of science dedicated just to the study of carbon. It's that important of an element. So the first particle we're going to talk about is protons. They're positively charged and they're found in the nucleus. And they have a mass of 1 AMU. That means atomic mass unit. It's the unit we use instead of like grams. Because atoms are so small, it wouldn't make sense to measure them with grams. So we measure them with atomic mass units instead. So how many protons does carbon have? Well, we're going to look at this top number here. This is called the atomic number. And it tells us how many protons carbon should have. So what we're going to do is we are going to represent carbon with clay and a paper plate. So here we have an image of, this is going to represent our atom. And since we're building carbon, we want it to have 6 protons because the atomic number right here is 6. And they go in the nucleus, which is the center of the atom. And I would like to ask you now, what is the charge of the atom? Well, 6. 6 what? 6 protons means 6 positive charges. 1, 2, 3, 4, 5, 6 positive charges. So that means our atom right now would have a charge of +6. We don't want our atom to have an overall charge. We want it to be neutral or have no charge. So what we're going to have to add in, so right now it has a +6 charge. See all those positive charges in our atom? We're going to need to add in electrons. These are negatively charged particles found not in the nucleus, and they have a mass of almost 0. So if you think of the stereotypical scientist, are they going to say, oh, let's just ignore the mass of the electrons? Well, they do, and that should tell you how teeny these electrons are, and make them small enough out of clay to do justice to their real size. Okay, but I'm going to put 6 tiny electrons on the outer edge of my plate. Why am I putting 6? It's because I want my atom to have no overall charge. I want it to be neutral. And these were 6 positives, so I also am going to need 6 negatives if my atom is going to have no overall charge. So what's the overall charge of our atom now? It's neutral because of the equal numbers of protons and electrons. But what is the mass of the atom as it stands right now? The mass of that atom is just 6. These electrons, remember, are so small that they can't play a role in the mass. So only these count towards the mass. The mass is 6. But if we look at the mass on the periodic table and we round it to find the mass of the average carbon atom, we'll see the average carbon atom should have a mass of 12. Right now it only has a mass of 6. How do we fix that? Well, we need to add 6 neutrons. So these yellow clay are going to represent our neutrons. And they should be the same size as our protons because they weigh the same. And they should all be in the nucleus. So the neutrons are neutrally charged. They have no overall charge themselves. They're found in the nucleus and they have the same mass as a proton. So we've now built the atom carbon. Okay. So this is how we found the mass. 6 protons plus 6 neutrons equals 12. Okay, so on the periodic table, this is the information you would need. Atomic number tells you the number of protons and the number of electrons if the atom has no overall charge. And the mass, you have to first round it, and then that should be protons plus neutrons. Okay, here's a review of the number of steps. Now let's practice with making the atom nitrogen. Okay, we need 7 protons. How do we know that? The atomic number tells us we need 7 protons. What is the charge of this atom? Positive 7. I don't want my atom to have a charge of positive 7. So I need to put on 7 electrons. So here I have 7 negative electrons, 7 positive protons. The charge cancels, so my atom has no net charge. What is the mass of my atom right now? 7. What is the mass supposed to be? Round this number, it's supposed to be 14. How do I get to 14? I add in 7 neutrons. Okay. Now, a lot of times at this point, kids think, oh, well, the number's always the same. For carbon, it was 666. And for nitrogen, it was 7 of each particle. Watch out, though. That is not always the case. So to demonstrate to you that the number of protons, neutrons, and electrons are not always the same, let's look at an average atom of lithium. How many protons do I need? The atomic number is 3, so that means I need 3 protons. What is the charge of my atom right now? Positive 3. I don't want it to have a charge of positive 3. So I put in 3 negative electrons. Now my atom has a charge of 0. Protons and electrons cancel each other out because there's 3 of each. What is the mass of my atom right now? 3. The electrons don't count in the mass. What should the mass be? The average atom has a mass of 7. So how many neutrons do I need? I need 4 neutrons in order to make my atom weigh 7. So please watch out for that. That catches kids every year. Finally, here are a couple more notes that you might want to write down. Just what the atomic number is, what the atomic mass is, as well as you might want to pause the video and write down these tricks on how to find the number of protons, neutrons, and electrons. Have a great day.